Hello everyone, welcome to Chemazon-Complete Chemistry. So this is the section C, that is the numerical answer type. First we will discuss question number 41 to 50 and then we will discuss the last 51 to 60 questions. First question is the degree of unsaturation for the compound is. So there are different ways to find out the degree of unsaturation. The most easiest and the fastest way is you can remember it by using this formula. Degree of unsaturation is equal to C plus 1 minus of H plus X minus N divided by 2. Okay, you can remember this formula. What is C? C is the number of carbon atoms. H is what? H is the number of hydrogen atoms. X is halogen. It can be fluorine, chlorine, bromine, iodine. N is what? N is nitrogen. Okay, so let us write down all the values. Carbon, how many carbons are present? 4. Hydrogen is how much? 4. Halogen is how much? 2 fluorine and 1 bromine. So halogen X is equal to 3 and nitrogen is also 1. Okay, so degree of unsaturation, I can write it as DOU in short, is equal to carbon is 4 plus 1 minus H is how much? 4 plus halogen is 3 minus nitrogen is 1 divided by 2. 4 plus 1 is 5 minus 4 plus 3 7, 7 minus 1 is 6, 6 divided by 2 is 3. So the correct answer is 2. How will you put? You will just write the number 2. Okay, integer value means no decimal places. Okay, you don't have to write 2.0. Okay, only 2. Second question, the kinetic energy of an electron is this much. The wavelength of the electron is how much? So kinetic energy is given 3.0 into 10 raised to minus 25 joules. What we have to find out? We have to find out is the wavelength of the electron in Armstrong. Okay, what is 1 Armstrong? This also we must know. 1 Armstrong is 10 raised to minus 10 meters. So we have to bring the final answer to this. Now let us solve. This is from which chapter? It is from atomic structure, or we can say structure of atom. Okay, it is based on which equation? Lambda is equal to h by t. Okay, what is lambda? Lambda is wavelength. Lambda is wavelength. H is the Planck's constant. T is what? T is the linear momentum. Okay, what is the formula for kinetic energy? Kinetic energy is half mv square. Okay, what is the formula for linear momentum P? It is mass into velocity. So what I can do? We want the relation between lambda, wavelength and what? Wavelength and kinetic energy. So we have to find out the relation between kinetic energy and linear momentum. Okay, so what I can do? I can multiply and divide by m. Okay, they get cancelled, so overall value is still the same. M into m is m square v square divided by m. M square v square I can write it as mv the whole square. Mv is what? Linear momentum. T square by, I missed this 2. So m square v square by 2m. So the final relation is kinetic energy is p square by 2m. What will be linear momentum? P square is equal to 2m kinetic energy. P will be root of 2 into m into kinetic energy. This we have to substitute where? We have to substitute in this equation. Okay. So we have to substitute in this equation. Lambda is equal to h upon root of 2m kinetic energy. What is the value of H? H is Planck's constant 6.626 into 10 raised to minus 34 joule second. This I can write it as joule is kg meter square second raised to minus 2 into second. Minus 2 plus 1 becomes what? It becomes minus 1 divided by root of 2 into mass of an electron is how much? 9.1 into 10 raised to minus 31 kg. Okay, I've purposely not given these values because you are supposed to know the value of Planck's constant, mass of electron. You must know mass of electron and Planck's constant values. Into kinetic energy is how much? Kinetic energy is 3.0 into 10 raised to minus 25 joule. Again, here I can write it as kg meter square second raised to minus 2. Now this is a root. Okay, so kg into kg will become kg square. So I can bring out kg outside the root. Then there is meter square. Outside the root it will become meter. Second raised to minus 2 becomes second raised to minus 1. Numerator we have kg meter square second raised to minus 1. Sorry. Now if we cancel the units, kg gets cancelled. Mass meter and meter get cancelled. Second inverse get cancelled. The final unit is in meter. Okay, you solve this entire thing. How you can solve this in calculator, that also I will tell you. First you put this value in the calculator. Okay, this into this into this. Then what you will do, you will use the square root, this symbol or this symbol. Okay, whichever is available in the calculator, you can use that. Okay, whatever number you get, you press a button called as memory save, MS. Okay, that will that will save this value, denominator value. Then you clear all. Then you put this value 6.626 into 10 raised to minus 34. Okay, you type this, you use this divide sign, and then you will use this mass memory release, MR. First memory save. Okay, and when you press memory release, that number will come after this divide. So in this way you can save your time. Okay, so what will be the final answer for this? Final answer is going to be 8 point. Okay, I'll write down the final answer here. 8.967 into 10 raised to minus 7 meter. Okay, we want in Armstrong. So 10 raised to minus 10. So we'll shift like this. 8967 into 10 raised to minus 10 meter. 10 raised to minus 10 meter is Armstrong. So the final answer is 8967. Okay, it is 8967. Okay, 8967. Here it will not be up to 3 decimal places. It is going to be okay, nearest integer. Okay, next one, the number of unpaired electrons in cobalt NH362 plus is, this is important. Okay, remember whenever we have an ammonia ligand, there are two cases. Okay, either the metal is in +2 charge or the metal is in +3 charge. If the central metal ion is in +2 charge, then ammonia behaves as a weak ligand, and if it is in +3 charge, then it will behave as a strong field ligand. Okay, now if you have considered the CFSC and if you have considered this as a strong field ligand, then your answer will be incorrect. Okay, you have to remember this. Oxidation state is +2, so the ammonia will behave as a weak field ligand. Okay, now first step is find out the oxidation state of cobalt. CONH3 2 plus. X plus 6 into 0 is equal to +2. So X is equal to +2. Ammonia is a neutral ligand, so charge is 0. Okay, cobalt 2 plus, what is the electronic configuration? D7. Okay, D7, 6 ligands, so it's an octahedral complex. Okay, it will split into higher level Eg, lower level T2G. Now we have to fill what? We have to consider this as a weak field ligand. So 1, 2, 3, 4, 5, 6 and 7. So you can see how many unpaired electrons are present? 1, 2 and 3. So the correct answer is going to be 3. Okay, you just write 3. Now let us see this question. Sum of the bond orders of superoxide, peroxide and dioxygen. Now purposely I have given you this name because if you don't know the names or formula of this, then you cannot solve this question. What is superoxide? Superoxide is O2 minus. What is peroxide? Peroxide is O2 and charge is 2 minus. What is oxygen? Oxygen is O2, 0 charge. Okay, we will start drawing the orbital diagram for O2. Okay, first we write 1s, sigma 1s, sigma star 1s. I am drawing only the molecular orbitals. Sigma 2s, sigma star 2s. Okay, then we have like this. Okay, sigma 2px, pi 2py, pi 2pz. This is pi star 2py, pi star 2pz and sigma star 2px. Okay, what we are interested in only this 2p orbitals. Okay, here we will be filling how many electrons? We will be filling 1, 2, 3, 4, 5, 6, 7, 8. O2, one oxygen has 8 electrons. So 8 plus 8, 16 electrons we have to fill. Okay, we have already filled how many electrons? 8 electrons. Okay, I will remove this name so that you can see clearly the electron filling. Okay, 16 electrons. So 8 are already filled. So 1, 2, 3, 4, 5, 6, 7 and 8. Okay, these are anti-bonding orbitals. I will just add the star so that we can come to know. How do we find out the bond order? Half into number of electrons in bonding, 2 plus 2 plus 2, 6. And minus number of electrons in anti-bonding orbital is 2. 6 minus 2 is 4. 4 divided by 2 is 2. So what is the bond order for oxygen? It is 2. Okay, now we can find out the bond order for O2 minus. O2 minus means we have to add 1 electron. Okay, 1 electron is added. So bond order for O2 minus will be half into bonding electrons are still same. 6 minus anti-bonding, now there are 3. 6 minus 3, 3 divided by 2 is 1.5. So for peroxide it is 1.5. Now O2, for superoxide O2 minus it is 1.5. Now we have to find out for peroxide. So we have to add one more electron. One more electron. So this 3 becomes 4. This will be for O2, 2 minus. 6 minus 4 is 2. 2 divided by 2 is what? It is 1. Okay, so this is 1. Now what we have to do? Sum. Now what is the meaning of sum? Okay, sum means addition. Okay, you have to add. Subtract means minus. Product means you have to multiply. Okay, so sum means you have to add all of them. Let us add all the values. 1.5 plus 1.0 plus 2.0. Okay, now this is in decimals. So you have to add that value only. 1.5 plus 1 is 2.5. 2.5 plus 2 is what? 4.5. So this is the final answer. 4.5. 45. 99% of the first order reaction. Okay, it is given that it is a first order reaction. Is completed in 32 minutes. Okay, time is 32 minutes for the first case. And 99% is reacted. Okay, the time taken for 99.9% of the reaction in hours. Very, very important. Check the units. If you have solved blindly and if you have found out the value in minutes and you have substituted, then your answer is going to be wrong. Okay, so first we have to use the first order kinetics. First order kinetics formula. What is that? Kt is equal to ln A0 by AT. Okay, what we have to find out? First, we can find out the rate constant. K is equal to 1 by 32 minutes. Okay, I want the answer in hours, so I will convert this in hours. 1 hour is 60 minutes. Okay, so 32 minute will be how many hours? Let's say x. So x will be 32 divided by 60. Okay, so what I have to do? I have to divide this by 60, and now my unit is hour. Okay, 32 divided by 60, what I can do? I can bring it to the numerator into ln of initial concentration. Let's say it is 100%, and 8 is after time t, after 32 minutes, how much is reacted? 99% is reacted, means how much is remaining? Remaining is 100 minus 99, so 1. Okay, this if you solve, the value of rate constant comes out to be 8.63 hour, 8.63 hour inverse. Now we can calculate the time. 1 by 8.63 hour inverse ln of 100 divided by, now how much is reacted? 99% is reacted. So now 100 minus 99.9 is how much? 0.1. Okay, 100 minus 99.9 is 0.1. 0.1. Okay, 0.1 is nothing but 10 raised to minus 1. This will go to the numerator. It will become 100 into 10, that is 1000. Solve this. The final answer in hour comes out to be 0.8. Okay, up to 1 decimal place. So you will put the value as 0.8. 1 decimal place means after decimal. Decimal is this point. After point there should be 1 digit. 46. What is the overall percentage of formation of E? Okay, so there is a linear synthesis. This is a, we call this as linear synthesis. That is, we start from reactant A is converted to B, C is converted to D is converted to E. What is the meaning of this? A to B percentage yield is 90%, B to C is 80, C to D is 55%, and D to E is 42%. We want the overall percentage yield from A to E. How do you find out? Okay, it's very simple. Overall percentage yield is, you convert all the yields into fraction. 90% is 0.9. Okay, and multiply them. 0.9 into 0.8 into 0.55 into 0.42. Okay, it is very important. This should be in fraction when you multiply. Okay, this entire thing when you multiply, it is going to be 0.166. Now, if you put the answer as 0.166 without seeing this point, they have asked in integer. Okay, I want the answer in integer, nearest integer. And what is asked? It's a percentage yield that is asked. So it should be in percentage and not fraction. I have to multiply this by 100. It will be 16.6%. Nearest integer I will round off to. This is greater than 5. So add 1 digit here. So correct answer here, it is going to be 17. Okay, correct answer is 17, 17. 47. Number of 6-membered rings and 5-membered rings of the heme complex is what? Okay, for that you must know the structure of this. Okay, if you don't know the structure, there is no problem. I will teach you how to draw the structure of this porphyrin ring and iron complex. That is the heme complex. Iron in the center. You draw 4 pyrrole rings like this. Okay, it is a 5-membered ring. Pyrrole, you know the structure of pyrrole. Okay, even if you don't draw it completely, that is fine. Okay, because we just want to see the total number of rings. Now after drawing the 4 pyrrole rings, join this. Okay, we start numbering from here. Okay, 1, 2, 3, 4, 5. Join the 2 and 5 position of all the rings. How? Let us see. Okay, and in between you have to add one carbon like this, just like some bridge. Okay, remember only the carbon, or you can remember carbon next to nitrogen should be joined. Okay, and this will form the coordinate bond like this. Okay, now count the number of rings that is formed. 1, 2, 3, 4, 5 and 6. So this is one 6-membered ring. This is second 6-membered ring. This also, if you count, it is going to be 1, 2, 3, 4, 5 and 6. This is third 6-membered ring and this is fourth 6-membered ring. So 6-membered rings are 4. And what are the 5-membered rings? 5-membered rings are this pyrrole rings. 1, 2, 3 and 4. Again it is sum. Okay, 5-membered rings are 4. Sum means add both of them. 4 plus 4 is 8. So the correct answer here is 8. Next one, 48. Enter the number according to the intermediate formed in the reaction. So this is a reaction between CHCl3's chloroform and base is added NaOH. Some intermediate is formed that will react with this ethene and form this compound. We have to find out the intermediate X. Okay, let us see the reaction. C, Cl, Cl, H, Cl. Okay, this is chloroform. OH minus is a strong base, so it will abstract this proton. Proton is abstracted, so the electrons are added here. Okay, so I can remove this now. Okay, electrons are added on the carbon, so lone pair and negative charge. Now, Cl will go away as a leaving group. So we will get a positive charge. So positive negative gets cancelled and this is the species that we get. Okay, it doesn't happen like this, but just for understanding I have drawn like this. This is which intermediate? Carbon having a lone pair and two other groups. This is what? This is a carbene. Okay, how the further reaction would have taken place? Further reaction would have been like this. CH2 double bond CH2. This will react with dichlorocarbene. This is called as dichlorocarbene. Okay, this will break like this. Okay, one electron of this and one electron of this will form this bond. Similarly, here one electron of this and this will form this. So that's how we get this 3-membered ring. Okay, so it is a carbene. So the correct answer is 4. Calculate the value of N or the number of electrons transferred for this reaction. Okay, this is the cell representation that is given. In the left, it is an anode, we know, where oxidation takes place. Here, reduction takes place. Okay, what we have to do, we have to write down the cell reactions. At anode, zinc will undergo oxidation, loss of electrons. Okay, and at cathode, what will happen? Fe3 plus will gain 3 electrons. Okay, that is gain of electron is reduction. Now we have to write down the net cell reaction. For that, what should be the criteria? That electrons should be same. In a hurry, if you have written the answer as 2 or 3, then the answer is going to be incorrect. What you have to do is you have to multiply by a factor such that what will happen? The total electrons get cancelled. So here it is 2. I can multiply this by 3. 3 into 2 is also 6. So 6 and 6 will get cancelled. Okay, so multiplied by 3. So this will be 3, 3, 3 2s are 6. Here also 2, 3 2s are 6 and 2 Fe. Now we can cancel this. So how many electrons are involved here? Correct answer will be 6. Okay, what will be the net cell reaction? 3Zn solid plus 2Fe, 3 plus aqueous, will give 3Zn2 plus aqueous plus 2Fe solid. Okay, so what is the correct answer? Correct answer is 6. 50. The operator d by dx is a eigenfunction of this. This is the wave function that is given. The eigenvalue obtained for the reaction equation is what? This is from quantum chemistry. This is which topic? This is called as eigenvalue equation. Eigenfunction, eigenvalue equation. Okay, what is that? We will see now. Eigenfunction, eigenvalue equation. Okay, so there is an operator. Let's say it is any operator A. You apply it on a wave function psi. What is the meaning of operator? Operator is same as plus, minus, division, multiplication. These are also what? These are also types of operators. Okay, it can be any. It can be d by dx. It can be integration. It can be double derivative d square by dx square. Here it is d by dx. Okay, you apply this operator on the wave function. If you get the wave function back, okay, if you get the wave function back, then it is called as, then that wave function is called as eigenfunction. And the value that we get here, let's say small a, this value is the eigenvalue. This is the value that we have to find out. Okay, so what we can do, we can start solving now. Operator is d by dx. Derivative, single derivative, you have to apply on 5 into e raised to minus 5x. Okay, 5 is a constant, so I can take outside d by dx of e raised to minus 5x. Okay, derivative of e raised to x is what? E raised to x is same. E raised to x into derivative of this power, derivative of minus 5x. Okay, minus 5 is constant. 5 e raised to minus 5x into d by dx of x. This is what? This is 1. Okay, and there is minus 5 as well. So this is the final answer. Minus 5 into 5 into e raised to minus 5x. If this you have solved, minus 25 into e raised to minus 5x. Okay, and if you have marked the answer as minus 25, then your answer is not correct. Okay, minus 25, or let's say even plus 25 if you have written, then also your answer is not going to be correct. Why? Because we want the wave function back. Okay, wave function should be back. What was the original wave function? 5 into e raised to minus 5x. Okay, so this is the original wave function psi. So what is the value of eigenvalue? Eigenvalue is minus 5. This is very, very important. Okay, if you write 5, then also your answer is gone. First you add this minus sign and then 5. Okay, I hope you have understood the solutions. We will see the remaining solutions in the next video. Thank you so much.